This building sits in the middle of the Utah desert. Outside temperature 102 degrees Fahrenheit. You walk through the door. It is 73 degrees inside. There is no air conditioner, no compressor, no refrigerant. The only electricity running to the cooling system is a single pump smaller than most people's coffee makers. That building exists right now. It was built by the National Park Service working with the Department of Energy's own National Renewable Energy Laboratory. They measured 67% energy cost savings. They published the results. The data has been public since 2002. You are paying $719 this summer to stay cool. In Texas and Louisiana, that number hits $858. Not because the problem is hard, because the solution this building uses has been systematically left out of every home, every neighborhood, and every building code written for the American residential market. This technology is 3,300 years old. There is a painting of it in the British Museum. Napoleon's army documented it in every house in Cairo. A study published last year found it reduces cooling load by 73%. And the American HVAC industry, an $88.9 billion industry, earns nothing, not a dollar, when you build one. In this video, we're going to expose exactly what this system is, why a federal laboratory proved it works in American desert conditions, and why the building code, the mortgage system, and the industry that profits from your monthly power bill have made sure it almost never gets built. It starts with a pharaoh, a rooftop tower, and a solution so effective it was the standard architectural feature of every home in the world's hottest city for 3,000 years. The year is 1300 BC. The house of Pharaoh Nebamun stands in the Egyptian sun. The outside air is brutal. This is North Africa in summer, 3,000 years ago, with no glass, no insulation, no modern building materials of any kind. But the paintings on the tomb walls that survive today, now displayed in the British Museum, show something extraordinary on that rooftop. Two triangular structures, pointed north, catching the prevailing breeze and channeling it down through the building. No fuel, no fire, no mechanism beyond the shape of the structure itself. This is the wind catcher, known as Malkoff in Egypt, Badjir in Persia, Barjeel in the Gulf states. And when Napoleon's expedition artists documented Cairo in 1798, they recorded that nearly every single house in the city had one on its roof. For 3,000 years, the people living in the hottest region on Earth had solved indoor cooling so completely it became the default feature of every home they built. The physics are simple enough to explain to a child. Hot air is lighter than cool air. Lighter air rises. A tall tower on your roof catches wind at the highest point, where air is moving faster and is naturally cooler than at ground level. That air is channeled down through the shaft into the living space below. Hot air already inside the building rises and exits through high windows or vents. The house breathes, continuously, without a switch, without a bill. The Persian engineers took this further. They passed the incoming air over water, such as a pool, a fountain, or channels running beneath the floor. Water evaporates. Evaporation absorbs heat. The air arriving at the level where people live is not just moved, it is cooled. A study published in the International Journal of Architectural Heritage in 2025 modeled this combination using modern computational fluid dynamics and found it reduces total building cooling load by 73% in hot seasons. 73%. From a tower and water. The system works even without wind. The height difference between the tower opening and the living space creates a pressure gradient. Warm air inside, being less dense, rises and escapes. Cooler air is drawn down from above. The same principle that makes a chimney draft works in reverse to cool the space below. Archaeological excavations in the 1970s near Shah-Rud, Iran, uncovered wind catcher structures estimated at 3,000 years old. In the desert city of Yazd, hundreds of these towers still stand. The tallest, at Daulatabad Garden, a UNESCO World Heritage Site, reaches 34 meters. Traditional Persian water reservoirs use them to store water at near freezing temperatures during summer. The Yakhchal, an ancient Persian ice house, combined wind catcher cooling with evaporative effect to produce and store ice, while outside temperatures reached 100 degrees Fahrenheit. In the desert, without electricity, without refrigerant, hundreds of years before modern refrigeration existed. Now here is the number that matters. In July 2013, researchers from Weber State University visited the Zion National Park Visitor Center in southern Utah. The outside temperature was 102 degrees Fahrenheit, and relative humidity was below 20%. They walked inside. The interior temperature was 73 degrees. The building uses no conventional air conditioning. Its cooling system consists of passive downdraft towers, a direct descendant of the Persian badger, combined with natural ventilation through operable high windows. The only mechanical input is a single 1/3 horsepower water pump consuming 249 watts. After 2 years of continuous measurement, the Department of Energy's National Renewable Energy Laboratory published the results: 67% energy cost savings compared to a comparable conventional building. The park saves $16,000 per year in operating costs. The building was not more expensive to build than a conventional facility. This is not a prototype. It is not an experiment. It is a federal government building that has been operating for over 2 decades in one of the hottest climates in the United States, verified by the Department of Energy's own laboratory, with the data publicly available to any architect, any builder, any homeowner who looks for it. Over 7,000 commercial wind catcher systems have been installed in buildings across the United Kingdom in the last decade. The Council House 2 in Melbourne, Australia uses the same principle, 3-story passive cooling towers, as its primary cooling mechanism. Studies confirm temperature reductions of 10 degrees Celsius or more compared to outside conditions. The performance is not in dispute. It has never been in dispute. The question is why you have never seen this in a new home in your neighborhood. In 1902, Willis Carrier invented the first modern air conditioning system in Buffalo, New York. It was designed for a printing plant to control humidity and prevent paper from warping. It was never intended to be installed in every home. It was industrial equipment. By the 1950s, it was in every new American home. And by the time that transition was complete, the wind catcher, a system that had cooled human buildings for 3,300 years, had essentially disappeared from Western architectural practice. Not because it failed, because an industry generating $88.9 billion had been built around the alternative. The US HVAC market generates $88.9 billion a year. Globally, it is a $310 billion industry growing at 6.4% annually. That industry depends on a specific structure. You install a system with a compressor, a refrigerant charge, filters, ductwork, a control board, and a service contract. The system requires annual maintenance, and it requires replacement every 15 to 20 years. It requires electricity every hour of every summer day it runs. Every component in that chain is a revenue source. A wind catcher has no moving parts, no refrigerant, no filters, no compressor, no service contract, no replacement schedule. It consumes no electricity for cooling. No one profits when you build one. Not from manufacturing it, not from installing it, not from maintaining it, not from the power it does not consume. That is not a conspiracy. It is a structural reality. And a structure does not need to be actively malicious to produce a specific outcome. Here is the mechanism that keeps wind catchers out of American homes. Modern residential building codes, specifically ASHRAE 62.2, the ventilation standard written into the International Residential Code, adopted across the United States, require mechanical ventilation systems in homes. This requirement emerged for a legitimate reason. As construction practices improved and homes became more airtight, natural air leakage was no longer sufficient to maintain indoor air quality. An airtight home without mechanical ventilation accumulates moisture, carbon dioxide, and pollutants. People understood this. But the solution the building code mandates is mechanical: fans, ducts, air handlers. There is no compliance pathway in standard United States residential construction for a traditional passive wind catcher system, not because it cannot deliver adequate ventilation. The NREL metering data confirmed it provides over 5 air changes per hour at the Zion Visitor Center, but because the standard was written for a world that already had a mechanical solution in place, and the entities with influence over those standards had every financial incentive to keep them pointing in that direction. A 2018 peer-reviewed study documented the consequence directly. In modern practice, wind catchers are being adapted as architectural decoration rather than functional systems, ornamental, a reminder of what used to be, not what still could be. In Egypt, the Malkoff functioned in every house for 3,000 years. It was abandoned within the last 50 years. Air conditioning now accounts for 60% of Egypt's peak electrical power demand. The country that invented this system is now paying for the electricity to replace it. No one had to ban the wind catcher. The building code, the mortgage appraisal system, the insurance structure, and the supply chain were simply never built around it. The system that replaced it had a supply chain, had manufacturers, had installers, had service technicians. There is no wind catcher lobby. There never will be, because there is nothing to sell. If you are building a new home or planning a major renovation in a hot, dry climate, in the American Southwest, the South, and much of the Sun Belt, the full-scale solution is documented and verified. It is a passive downdraft cooling tower designed on the Zion National Park model, integrated into the building envelope at the design stage. Weber State University research has already established that climate conditions in Utah and surrounding arid regions are equivalent to central Iran, where these systems have operated for 3,000 years. The construction cost is lower than a comparable conventional HVAC build. The operating cost is near zero for cooling. You are not building experimental technology. You are building what a federal government facility has been running for over 20 years in the American desert, with Department of Energy verification. For that design work, the Passive House Institute US and the Building Science Corporation published technical guidance on passive ventilation that architects familiar with the standard can apply. The UK commercial market has the most active development of modern wind catcher products, with manufacturer specifications that can be adapted for residential use. Now here's what the rest of you can do: the renters, the homeowners in existing houses, the people who cannot demolish their roof and start over. The principle scales down. The physics do not change. Turbine-style roof ventilators, the spinning aluminum vents you have seen on commercial rooftops, create the stack effect by drawing hot air out of the attic and upper floors. They are available at hardware stores for $30 to $100. Installed at the highest point of the house, they begin the same pressure differential the Badger creates. Pair them with this: north-facing windows kept closed during peak daytime heat, opened at night when outside air drops below indoor temperature. Position a box fan low in a window on the cool north side, drawing cooler outside air in at floor level. Position an exhaust fan high on the south or west side, pushing hot indoor air out. You have just created the directional air movement the wind catcher works on. Cool air enters low, hot air exits high, using $40 in equipment from any hardware store. This will not replace your air conditioner in Phoenix in August, but it will change what your air conditioner has to do. And understanding the principle that passive air movement can do work that electricity is currently doing for you is exactly the starting point the industry does not want you to have. The wind catcher is 3,300 years old. A government laboratory verified it in the American desert. Thousands of commercial buildings in the UK are running on it right now. The materials are available at any building supply store. The physics are in your favor. $719. That is the average American cooling bill this summer. In Texas and Louisiana, it is $858. And that number is the highest it has been in a decade. It will be higher next summer. You do not have to pay it. Not all of it. Not anything close to all of it. The people who understand what we have covered in this video are already making different choices in their design, in their renovation priorities, and how they think about the buildings they live and work in. Not because they have access to special technology, because they asked a question the industry does not want asked: what was working before the machine? The answer is a tower 3,300 years old, documented in the British Museum, verified by the Department of Energy, running right now in a government building in the Utah desert, where it is 102 degrees outside and 73 degrees inside on one pump that draws less electricity than a light bulb. There is no supply chain behind a wind catcher, no manufacturer making margin, no service technician billing by the hour, no utility meter spinning faster. That is not an accident. That is why you have never seen this on the front page of a home improvement magazine. That is why your architect almost certainly never mentioned it. A lot of what this channel covers was nearly lost, not because it stopped working, but because the industry moved on to something more profitable. If this is the kind of thing that matters to you, sharing it is the simplest way to make sure it keeps being found. Next, we are looking at the building material that outperforms insulated concrete, costs nearly nothing to produce, and lasts over 1,000 years with zero maintenance. Modern builders refuse to touch it. We are going to show you why.